Hey, welcome to Scienzyon. In today's video, we are going to discuss about Newton's first law of motion. So let's go right into the topic. The Greek thinker Aristotle lived in the 4th century BC, and he believed that if an object is moving, an external force is always required to keep it moving. According to this view, for example, an arrow shot from a bow is kept in motion by the air behind it pushing it in the forward direction. So, according to Aristotle, we can say that an external force is always required to keep an object in motion. Aristotle may have concluded this from his observation of everyday life. Like, if we allow a ball to roll down, after a certain distance, it slows down and finally it stops. So, it seems like Aristotle is right, but is he? Centuries after Aristotle's time, at Galileo's time, Galileo had done various experiments, like the inclined plane experiments. So he observed that the objects moving down an inclined plane accelerated. It means that its velocity increased over time. He also observed that the objects moving up an inclined plane decreased its velocity. That means it experiences retardation. The motion on a horizontal plane gave an intermediate situation. Galileo had conducted another experiment, a double inclined plane experiment, in which a ball is allowed to roll down an inclined plane and climb up another inclined plane. So what he has observed is that when a ball is released from a certain height, it rolls down that plane and climbs up the other plane and reaches the same height, or a little less than that, if the planes are smooth enough. If we decrease the slope, still the ball reaches the same height, but doing so, it has to travel a longer distance. So if we reduce the slope to 0, then the ball should travel through an infinite distance. But in practice, of course, the ball comes to a stop after traveling through a finite distance. This is due to the frictional force acting on the ball. So from this, Galileo concluded that there is no need of an external force to keep an object in motion. So if an object is at rest, it does not need an external force to keep it at rest. And if an object is in uniform motion, it does not need an external force to keep it in motion. So this resistance to change in the state of motion is called inertia. So Newton built on Galileo's idea and laid the foundation for mechanics. So Newton's first law of motion is actually Galileo's law of inertia. So Newton's first law of motion states that every body continues to be in a state of rest or of uniform motion in a straight line unless compelled by an external force to act otherwise. So if an object is at rest or it is moving with an uniform velocity, it does not mean that there is no force acting on that object. It only means that there is no net force acting on that object. This means that all the forces acting on that object cancels to 0. Consider a spaceship moving in the interstellar space away from all other objects. Even if its all rockets are turned off, the spaceship will move with an uniform velocity. Consider a stationary book placed on a table which is at rest. Now there is a force acting on that book, which is the gravitational force which is acting in the downward direction. But we know that the book is at rest. So there must be another force which is acting on it. So there is the normal force which is acting in the upward direction. That is, now the gravitational force and the normal force are acting in the opposite direction. So they cancels up to 0. And therefore the book is at rest. That is, the net force acting on that book is 0. So let us look at a everyday example of Newton's first law of motion. Consider we are standing in a stationary bus and suddenly the driver starts the bus. Then what will happen? Of course, we get thrown backward. This is due to the first law of motion. Our feet and the floor of the bus are in contact. So due to friction, when the bus moves, our feet moves along with it. But due to inertia, our upper body will try to remain at rest. And this is the reason why we are thrown backward when the bus starts. If there were no frictional force between our feet and the floor of the bus, then we will remain where we were, while the floor of the bus will simply slip forward under our feet and the back of the bus will hit us. But fortunately, there is a frictional force. The same thing will happen if a moving bus suddenly stops. But at this time, we would be thrown forward. So that's Newton's first law of motion. If you like this video, click the like button, comment, share and subscribe. So that's it for today's video.